Well, first things first. I haven't put an obvious space, but I would like you to, for the sake of when you leave it here, I know who to get it back to. Throw your name on the top here. This is Dawidoff's book, because that's who I am. And I'd like to throw the semester on here, so this is fall 2025. Throw your name on the top of the book, so if you leave it here, if you forget it, if you decide that you want to throw it off the rotunda, I can find out who it belongs to and return it to you, no questions asked. This is the booklet you're going to need for all of chemistry. If you forget this booklet, I have like 6 or 7 extras, and I always make one of them my loaner copy. If you've forgotten your book, ask me for the loaner booklet. I will give you the booklet. You'll fill out whatever it is, whatever notes we're doing on that day, tear them out of the loaner booklet, and then add them to the booklet that you forgot that's sitting on your desk or dining room table at home. So that you don't have to copy everything by hand onto paper and then copy it into your booklet or just shove random lined paper in there. Or even worse, just sit there and do nothing on block. So if you need a loaner, let me know. Inside front cover is the periodic table. You're going to get a few of these from me. This one is always one that you can reference. I'm going to give you a larger copy. Not today, but eventually you're going to get a larger copy of this as well. There are 4 of them up in the classroom. The most useful one is the big one on the front, but we do have 3 more on the back. And the reason I have so many is because they all actually technically have different information on them. You'll see that there's some missing off that middle one. There's a few more on that one. All of the elements are on that periodic table, and the information that provided on each one is slightly different. So, let us review, shall we? I don't know why, but the photocopier decided to chop off some of the letters on my question, or on my booklet. Chemistry introduction. All matter is made of what? You would have learned about this several times up till now. All matter has mass. What gives matter mass? Atoms. All matter is made of atoms. And all these atoms are different things. An atom is the smallest unit of an element. There are smaller things than atoms. There are things that make up atoms. But when you put those different things together in unique ways, you get the different elements. So an atom is the smallest unit of an element. And the elements are the things that you find on the periodic table. They are all different. They behave in different ways, and then when you combine them, they behave in yet more unique ways. I had a conversation with one of you guys a couple days ago, talking about table salt. Table salt is a compound, which we'll talk about later again, but table salt is made up of sodium and chlorine. Chlorine is a gas that you can weaponize and kill people with. Sodium is a metal that when you throw in water, it will spontaneously explode. When you combine them, you get this lovely little compound that we throw on top of fries, and it's good for you, which is weird. But these elements all have different properties. So an atom is the smallest unit of an element, and all of those atoms still have the same chemical properties. Chemical properties of that element. So when we're talking about chemical properties, you would have learned about them all in grade 9. Things like reactivity. What are the other chemical properties? Reactivity is the big one. There's a bunch of physical properties that you can look at too. But if we go down even further, atoms are all made up of more subatomic particles. How many are there? What are the subatomic particles that make up an atom? There are 3 of them. I list them for you right there. The protons, the neutrons, and the electrons. Protons, let's talk about that one first. We have the symbol for a proton. The symbol for a proton is P with a little plus sign above it. What's that little plus sign for? Because protons are positively charged. A single proton has what kind of charge? Or how much of a charge? We say that it has a charge of +1. Where in an atom do you find the protons? In the nucleus. It's one of 2 Subatomic particles you find in the nucleus. And the number of protons is equal to what? Not always. Throw your hand up because I want to call on more than multiple people. Sorry? No, it is not equal. Put your hand up because I want to talk to other people too. It is not equal to the number of neutrons. Yes. Dominic. The atomic number. So the number of protons is this concept that we call the atomic number. I've got a little square right here. This is a little square that you'd find on the periodic table. And this right here is the atomic number. And the example that I've given you is for titanium. So the atomic number of titanium is 22. And what that means is that every single atom of titanium everywhere is going to have 22 protons. If you somehow are walking out in the wilderness and you pick up an atom, you're like, how many protons are there? And there's 22 protons. You're like, this is titanium. That would never happen. But theoretically, if it did, that's how you'd identify what it is. The number of protons, tells you what atom you have. The other piece to this is that I didn't include as its own little bubble, so I'm going to put it right up there. What is the mass of a proton? Or how do we talk about the mass of a proton? Because at the beginning we said that all matter is made of atoms. One of you suggested that all matter is made of mass. This is true. All matter has mass. The mass comes from the protons and the neutrons that are present. How about the mass of a proton? Hands up. Hand up. I want to hear from everybody. Put your hand up if you got something to say. When do you guys, if I asked you what I'm not going to, but if I asked you what your mass was, you would give me your mass you wouldn't just give me a number. Your driver's license doesn't just have a number on it. It also has units. If I asked you for your mass, you would say you'd give me a number in what units? If I asked you what you weighed, how would you tell me? Yeah. Some of you would give it to me in pounds. Canada's this kind of weird country where we work with multiple units. You'd say, I weigh X amount of pounds. Some of you might know your mass in other units. What are the other units? Kilograms. So we either weigh things in kilograms, or we the mass of things either in kilograms or in pounds when we're talking about objects that are like your guys' size. For objects that are much larger, we might talk about them in tons. For objects that are really, really small, we have another set of units. We call them atomic mass units. And the proton is actually the definition for the atomic mass unit. A proton has a mass of 1 atomic mass unit. It's not pounds, it's not grams, it's not kilograms. Proton, we say, oh yeah, just to make things easy, make your life a little bit more calm. Proton has a mass of 1. A mass of 1 what? Well, it's the atomic mass unit. Whatever that means. It's too small to know any different. So that's the proton. You learned all about protons last year. The next one is neutrons. If a proton is P+, what might you suggest the symbol would be for a neutron? Ooh, is it N negative is the suggestion. What's the charge on a neutron? Neutron is a neutral charge. So what symbol might we use for a neutral charge? A 0. Neutron means the thing is neutrally charged. Means it has 0 charge. And so we use N0. Let's write down the mass right away. Neutrons also have a mass of 1. Gentlemen, what's going on? How did he way over there steal your pen? Oh, your bag? Hey, give him his bag back. Whoever has his bag, give him his bag back. Where's his bag? We will wait. As a class, annoyed. Where's his bag? Give it to him, please. Let's go. If it's not yours, don't touch it. I don't care. I don't care who it was. This is the kind of crap that I give you a seating plan for. Neutrons have a mass of 1 AMU. Same mass as a proton. Neutrons are found where? Someone whispered it. Also in the nucleus. And because the neutrons and the protons are both found in the nucleus and they both have a mass of 1, together, their combined mass is the value that we have here for the atomic mass. So the atomic mass here, when we want to use it for something, we round it to the nearest whole number. So the atomic mass here wouldn't be 47.9. We'd round that to 48 atomic mass units. If we wanted to figure out the number of neutrons, you would take the total atomic mass, the 48 AMUs, and we take away the other number that we know. We know titanium has an atomic number of 22. So 22 happens to be the number of protons. You take away the 22 AMUs of P+, and you're going to get that titanium should have 26 atomic mass units of neutrons. The number of neutrons is equal to the atomic mass minus the atomic number. Protons and neutrons have the same mass. They're made up of the same smaller particles. And then we've got electrons, the other atomic particle, subatomic particle. What's the symbol for an electron? Well, we had P plus N0, so an electron is probably... What's the letter we're going to use? E. And you're suggesting that the other piece of the symbol is a minus sign? E negative? So we've got P plus, N0, and E negative. Why is an electron an E minus? Because it is negatively charged. Someone said. Not only is it negatively charged, we can be more specific. Electron has what charge? -1. Where do you find electrons? Outside, yes. Outside the nucleus. So what you'd get here is something that looks like this. Let's draw a little picture here. I've got a bunch of particles clumped together in the middle. Some of these are going to be positively charged protons. Plus, 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 plus. Some of them are going to be neutrally charged neutrons. I got an N, an N, an N, an N. Another N. It's really hard to see, probably. And then outside that nucleus, you're going to have electrons existing, bouncing around in space, all around the outside of that thing. Protons have a mass of 1 atomic mass unit. Neutrons have a mass of 1 atomic mass unit. Electrons have a mass of 0.0054 AMUs. Very, very, very small compared to the proton and the electron. So small, we don't even count them. Their mass is not big enough to contribute meaningfully to the mass of an atom. And Dominic, you suggested that the electrons were equal to the atomic number. That's only true when? When are the electrons equal to the atomic number? This is something that you guys would have talked about last year too. Krishna, can you zoom in? Where, on this or on this? This little guy? Okay, so there it is. Some of these, I put pluses inside some of them. I put N's inside other ones to represent that the protons and the neutrons are in that little chunk. If you need me to slow down or zoom in, just all you gotta do is say something, and I will happily do that for you. Krishna, can I zoom back up? Good cat. Okay, so electrons are the same as the atomic number when? No. Protons and electrons are the same only for a certain kind of particle of an element. Okay, gentlemen, I don't know what's funny, but do you have an answer for me? Okay. Electrons are equal to the atomic number only in an atom. Because sometimes you can take an atom and you can turn it into an ion. I'm hoping things are coming back from grade 9. What's an ion? Who remembers Science 9? What makes something an ion? Yes, sir. Could be negative. A negative ionic charge could also be a positive charge. How do you get a positive or a negative charge on an... Like, how does an ion become charged? Do you remember? When it does that, what happens to make it positively or negatively charged? Everything you've said is correct. I just want to take it all the way to the end. You don't remember? Okay. So let's talk about ions. Everything you said was right. Let's just finish it up. Atoms have a neutral charge. So the definition of an atom is the charge has to be neutral. It means that they are neither positively charged nor are they negatively charged. The only way you can be neutral is if your protons equal your electrons. You have the same number of positives as negatives. But when these things bond to other things, something will leave one atom and join the other atom, and then you've got an imbalance of charges. What's the thing that leaves? The electrons. The electrons are the only things that are allowed to move. Ions are atoms that have either lost or gained electrons. Because the electron is outside the nucleus, it's the thing that's allowed to jump back and forth between the atoms. Electrons are negative. So if you lose an electron, and if an electron leaves, the charge on the atom is no longer neutral, it becomes positive. If you lose a negative, you become positive. And you gain as much positive charge as the number of electrons you've lost. So if you lose 3 electrons, your charge is now positive 3. If you gain an electron, if you gain something negative, the charge on your atom becomes... If you were neutral and start picking up a bunch of negatives, you become negative. So any element that receives a negative charge to become an ion has gained a whole bunch of electrons. Different elements behave differently in this regard, and you would have looked at these last year, so let's review them here. The periodic table is broken up into a bunch of different families. The first thing you look at in Science 9, for some of you, that might be a long time ago. You've got, if you look up at the periodic table, that first column. Let's get up. I don't want to sit anymore right now. Get my stick. Go point it. Periodic table. See if you, how many of you remember the families? What's this family called? Sorry? Ooh. The metals. Yeah, there's a whole chunk of this table that's metals. The metals go all the way to where? These are metals. This column here is a specific kind of metal. These are the alkali metals. The next one are the alkali earth metals. And the metals go, all the metals, if we just talk about metal atoms in general, or metal elements in general, the metals go all the way to where? Not all the way to the right. They gotta stop somewhere. Look at the table. There's a defining barrier in the table. Sometimes in grade 9 you call it the staircase. This line right here, this thick black one. The metals end just before you get to that staircase. On either side of the staircase, what do we call these guys? Sorry? The non-metals are on the other side of the staircase. Right along the staircase, we've got the semi-metals, or the metalloids. And then on the other side of the staircase, all of these guys up here are non-metals. And you can see how they behave as far as their electrons are concerned. All of the metals up to like here-ish form what kind of ion? Sorry? What does that mean? It's language we haven't used yet. What's a cation? A positive ion. If you look at the charge on all of these, when these guys become charged, they all become positive. All metals behave the exact same way. Metals they give up their electrons and they're happy to do it. If you like, here, you can have an electron. Just I want to get rid of them. All metals behave the same way. The number they give up is different, but that's what all of them do that. The non-metals are all these guys up here. And you can see all of the non-metals do the same thing too. They want to take. The non-metals are takers. The metals are givers, the non-metals are takers. Sure, you know metals and non-metals in your life. So all metals lose electrons to become positive. And non-metals, all non-metals will gain electrons to become negative. It's one way to determine what kind of element you have. So examples of these things. One example is chlorine. You stay on this page. I'll flip back here so I don't have to keep going over there. You would have studied the periodic table in way too much detail last year. So chlorine, it's one of those things you want to find is this guy right here. Up in the top right. The periodic tables that I give you have it labeled. This is the metals. These are the non-metals. You've got the gap down, or the staircase down the side here. So this section is the non-metal section. There's chlorine. And the way these things are read is that up in the top right on these guys, on this periodic table, that's the charge. So if there's just a minus sign, what that means is this thing has a charge of -1 when it becomes an ion. So we know a few things about chlorine. Chlorine is a non-metal. It's in the non-metal section. It has a -1 charge. And so what that means is to become an ion, chlorine has to gain 1 electron. An example of the other one is something like magnesium. See, some of you are so furiously writing. Okay, I'm going to flip back. You stay where you are. Magnesium's right here. It's up in the top left. And again, you guys spent a lot of time studying the periodic table. The left-hand side of the table, you guys should know are the metal side of the table. That's magnesium. You look up in the top right, it has a charge of +2. All of the metals will form positive ions. So, magnesium, a magnesium ion is metal. The charge on magnesium is +2. And so if magnesium as an ion has a +2 charge, what does it have to do? It has to lose 2 electrons. You bet. So let's review, shall we? When you're ready, flip the page. There's a table here. I will walk around and assist where needed. I'd like you to fill in the table. There are blanks everywhere. There's 2 rows of examples. Here are the examples. The first row, they tell you that the element you've got is potassium and it has the atomic number 19. If you take a look back at the periodic table, you say, okay, well, potassium atomic number is the number up in the top left. There's potassium. It's got the number 19. They've told you that the particular potassium you have is a charge of +1, and so the thing is an ion. If the atomic number is 19, that tells you that the protons is 19. Because this thing is not charged, or is charged rather, a charge of +1 means you've lost 1 electron. Atoms start with the same number of protons as electrons, so it started with 19 electrons. If you lose 1, now it has 18. And then to find the number of neutrons, what do we have to do? Well, we've got to go back and take a look at potassium. Potassium has a mass of 39. To find the number of neutrons, you take this number and this number, and you subtract the 2. So to find the neutrons, you took the 39, you rounded it to 39, you took away the 19, and that gave you the number of neutrons. This table is an exercise in reviewing how you find all these pieces. The next example says this. Well, you've got phosphorus. It's got atomic number 19, which is true. The ion charge is 0, which means you don't have an ion of phosphorus. You've got an atom of phosphorus. If you have an atom, it means that these two have to be the same. The protons and electrons are the same. And then to find the neutrons, you do the same thing we did before. You look at the mass, you take away the atomic number. So the mass of phosphorus, if you look at your periodic table, is 31. 31 minus 15 is 16. If you need a calculator, you can borrow one from me. What I'd like you to do is I'd like you to fill out the rest of the chart. If the charge is 0, it's an atom. If the charge is positive or negative, it's an ion. And I will help where needed. On your mark, say giver. How can I help you? Some of you are sitting there being like, I have no idea what the heck is going on. That's okay. Call me over. Fill out the chart. Good. Okay, fantastic. Yes. I see that. So if there's, depends on if it's charge. So if the charge is zero, they're telling you in this particular that the charge is zero. If the charge is zero, like this one, the protons and electrons have the same thing. So the charge is plus one, or like this one here. If there's a negative charge, how negative means you gain this one. You take the number of protons. So for this one, if it's positive one, that means to become positive, you lose electrons. So you take away the number of protons, and you take away the one electron.
That's zero. That's
Yes.
so it's the same thing with atomic mass.
So right.
Going at it fast.
You're around the 6.9 to 7. Yeah. So you did 7 minus 3 is positive. Yeah, that's right. That's true. So if you positive number, you can't have a negative number of particles. Yes. Yes, you round up. Well, depends what the number is. You round it however you round. So which one are you looking at? Yeah, so 6.9 rounds to 7. Yeah. So, but like if you add, like chlorine is 35.45, you take 35.4, you round that down to 35. You had a question, you had your hand up.
Yeah.
Okay, what's up? The atomic number is 7. Okay, so then the atomic number of nitrogen discussion. So you said the atomic number for nitrogen is 7. Is that correct? That is correct. So then the atomic number, yeah. And it just comes off the periodic table. The atomic number is the same as the protons. So these two columns are always going to be identical.
Okay. So this is 3.
And then this one, yes, as you just said, if the charge is -3, that means you've gained 3 electrons. So this electron is negative. You started with 7, you got 3 more. Now you're at 10. Okay, I'll say that again. So So when you start like with nitrogen here, when you start with a nitrogen atom, protons and electrons are the same. So you start with the 7 protons, and an atom is going to have 7 electrons. But nitrogen is now this nitrogen is charged with -3. It would be 7 plus 3 actually. Yes, because every electron is negative. If you have a negative charge, it means you gained electrons.
So then this, you're subtracting.
Yes.
Yep.
Yes.
And then.
Sorry, which one are you pointing out? No, this one, so this one is the neutrons. This one now, to find the number of neutrons, you have to go back and look at the mass. You take the total mass, after you've rounded it, so nitrogen has a mass of 14.01. So you round that to 14, and then you take away the number of protons, and that will give you the number of neutrons. Protons and electrons are the same, yes. Yes. Because there's 0 charge, and those 2 columns are the same. Those guys have no charge. That whole column. So you can use the periodic table on the inside cover of your notes, or you can use the ones on the walls. Yeah, but that is nothing to do with neutrons. So this is what he has to on his bag.
How are you adding? Where are you going?
I would have done it. These don't work. Calculator, I'm gonna put in the sleeve hanging up under the board. If you wanna take a calculator, phone in there and then take the calculator. And you give your calculator back, take it back. Or you can show it. Something of value.
Wait, huh?
I'd say
That's 11.
So for that, I'm telling you because that particular question is a chlorine atom. If it has a chlorine, anything that's a good, that's low charge. Like these ones, phosphorus, I tell you, is it's an atom. There's no charge. Lithium atom.
The number of electrons.
Boron atom, chlorine atom, fluorine atom. It means that means is that the protons are the same. You're right. Chlorine turns into an ion. It would be minus one charge. Then these two numbers would be different. You don't have it. So the reason that's zero is because I'm telling you, you don't have an ion.
I can't see.
Which one?
Like this, I can't like read them. These are both words.
Very small. Like it, like.
Oh, you were saying right back.
This song. I was gonna hold off on giving this to you, but some of you guys are frustrated by the small printing on the one that you have already. Hands up if you would like a gigantic periodic table. You know what, I'll just come table with table and ask. Your hands back, you work. Okay, the ones that you periodic table. There is a gigantic one you got. Okay, there you go. They're yours now. All five of you. Actually, you don't have to sit. You can give it back. You don't have to. You can keep this if you like. Would you like a China one? All three of you right now. Go. All four of you like on the base. Okay. Two of you. When you you want a big one? Okay. Okay, who would like a gigantic periodic table? Would any of you? Okay, there you go. Any of you guys want a big one? Yeah, you bet. If you don't want to hang on to it, you can return it to the pile here at the front. If you do want to hang on to it, fold it in half, and it's the same size as a regular piece of paper.
What's the number of electrons?
Oh.
No. Protons and neutrons. If you find the charge, no, the mass is the same. To find the number of neutrons, you take the atomic mass, 48. You take this one, you round it, the nearest one number, so 37. And you take away the atomic number. This is the number of protons. Take the mass minus the protons.
So basically, it's always going to be.
Are you adopted? Are you adopted? Are you adopted?
There's no charge. None of those guys have it.
Are you adopted? What's the next level?
We'll get them back. We'll get there. Yes, because there's no charge for the protons. For the neutrons, you don't look at the mass. The mass. So value is now there. So 6.968, you're on 6.927. And you subtract.
Are you
you must have.
Well, it's all time.
Okay, how we doing, gentlemen? Okay. You go on.
Then you have to do that.
Now you give me a second when I'm all done. Help your buddies, because you're the only one down at this table. Help each other, don't just copy. So explain it, I'll just show you if you're working. Okay. So then put your book away. So then don't let him copy you, or if you've explained it to him, let him do it. You can compare when he's done. Yes.
You know how you get that?
Is that me? I don't think so. You can go along. It's up.
So basically on.
So that means if it's charged, the charge will be -1. And then they tell you that this particular chlorine has no charge. So chlorine can either have, so all of these atoms, for all of these elements can either have a charge of 0, if they're an atom, or whatever's written on the table. I tell you the charge here is 0, what do you think? Because this thing's an atom, not an ion.
Oh.
So then protons and electrons would be the same.
When you go
Go down the bar.
protons related,
Yeah.
protons related,
This electron is well, that's it. He gives it
Okay. Let's crank this out, shall we? 3, 20, nitrogen,
what's your favorite element?
7, that's 18, 5 is boron, number 20 is calcium,
No, carbon.
My bad.
number 3 is lithium,
Neon.
number 13 is aluminum, chlorine is 17, that's 11, that's 11, 11 is sodium, so it's going to be 7, 5, 18, 13, 17, 0, 17, that's 5, that's 10, that's 18. That counts. You bet. I had 2 out. When one of them comes back, Krishika or Olivia. When either one of those comes back, you can go. 3, 3.
I just needed that.
0. So that's going to be positive 3, positive 1. The mass of lithium is going to be 4. The mass of calcium is going to be 2. The neutrons are going to be 2. Nitrogen is going to be 7. Boron is going to be 6. Argon is going to be 22. Aluminum is going to be 14. Chlorine is out of 36 minus 17 is 18. So it's going to be either 18 or 19, depending on the table that you use. And sodium is 12. Okay.
Jihad, you can go. Okay. Making progress.
Where's Agnes?
No.
No. Why are you calling me?
And Ron is the new dog.
No.
You go one roll then.
Besides.
Pause questions here first.
Nitrogen.
Okay.
And Ron, how does Agron have 18 How does Agron have
I finished it.
Look, they have ionic
Good.
charges.
Your bureau was good.
Because it's all the stuff with CT. Where did you?
We get.
Okay. So the 18 comes from comparing the charge and the number of protons. So if the thing is charged, you have to look at the number of protons, because you always start with the same number of protons as always. They start the same. And if the charge is positive, it means one of the atoms is negative. So it's always this minus this number. So 19 minus positive 1 is 8. 15 minus 0, because there's no charge, it means these two are the same.
Come on, are you gonna use
Same here, the charge is 0, it means electrons and protons are the same. Here, if you have 20 started and your charge is plus 2, it becomes lost electrons. He said, 18. This one here, whatever this number is for nitrogen, this has a negative charge, so it's gained in it. So it'll be the number of protons plus 3. Given by the negative charge.
Layer 1.
I don't even want
You guys are almost done.
Hey, remember that big use amount? Here you go, you pay the other one. Should have got you over here.
We know now, there's only one else.
What is that?
Yes.
I
Yes. Sweet, I got my answers on the screen in a second. I'm just gonna let a couple of that information, sorry.
It's the
On this chart, compare these two numbers. If they're the same,
It's just saying you're Maureen, 35. Okay. 35 minutes. Wait, look at my.
you guys are done. Yeah. Zero. So it'd be this.
I never. You. When she worked.
Well, I guess I couldn't say that. I think Arvin.
Not even doing me.
What is it called?
Fish one. You don't want to roll that. Top left. Okay, let's take a look. Lots of you are done. Boom. There are my answers. Compare what you got with what I got. If you didn't finish, take a picture of that.
compare your answers with mine, you'll notice at least one of them, the number of neutrons is, I've got two options for the number of neutrons. Because it depends which periodic table you look at, they have slightly different masses. If I got something different than what you got, don't assume that you're wrong. I could have made a mistake when I went through it. If you and I have different numbers, don't assume that you're the one that got it wrong. I could have gotten it wrong. Compare what you got with what I got. Are there any differences on your guys' table versus my table? Which one? Did I make a mistake? Maybe I did. Okay. I don't know. Which question? Did you get a different value than I got? For which one? The neutrons on aluminum?
Yeah.
Okay. Let's take a look. Maybe I messed that one up. Aluminum has a mass of, on this table it's 27. On that table it's 26.9, so 27. And it's 13, so 27 minus 13. That one, not the correct. So this is, I mean, technically speaking, it is a review. How do we feel about this? It's been, I know for lots of you, math or science time was a long time ago. And so, yes, I say it's a review, but if it's not easy, that's okay. I'm just hoping things come back. Yes, Eve. You got a different one than I got?
Yeah.
Which one? The chlorine? Okay, so for chlorine, it depends on, because of there, effectively you have three different periodic tables in front of you. You've got the one up on the wall, you've got the big one, those of you who wanted the big one. And on that one and the big one, the mass of chlorine given is 35.45, which on those periodic tables you'd round down to 35. So then to find that, you'd say, okay, well, 35 is the mass that we're going to use. The protons is 17. 35 minus 17 is 18. But if you use the periodic table on the inside front cover, you'll see that chlorine here has a mass of 35.5. If this is the table you're using, you're going to take 35.5 and round it to 36, and then take away the 17. 36 minus 17 is 19. So depending on which periodic table you're using, you're going to get different values for the neutrons. And the neutrons are the one, like protons are never allowed to change. Protons are protons, they stay the number that they are for the element that's given. Same with electrons. You will either have the same number of electrons as protons, or you'll have the number of protons that will match with whatever charge you're given. But neutrons are allowed to change. Neutrons, you can either be a couple up or a couple down. And we'll talk about what that, we're going to get to a section in the course on something called radioactivity. In the physics chapter, we'll talk about radioactivity. And with radioactivity, neutrons are allowed to change. That's what makes something radioactive or not. And if you have, so for chlorine, it can have 18 or 19. It can have 20, 21 neutrons, or 15, 16. Those are allowed. The neutrons are allowed to change is what I'm saying. This column is flexible. I still want you to calculate it using the information I'm giving you. But out in the world, these numbers, the neutron numbers, are allowed to change. And that gives us the concept of radioactivity, which we'll talk about in the physics unit, probably in December. Okay. So, excellent. We got about 20 minutes left. These concepts here give rise to a model that we can make for atoms. You would have looked at these last year. Bohr models. Hands up if you remember Bohr models. We looked at these. Fantastic. We're going to review them because we're going to use them for something new. So to make a Bohr model, how your Science 9 teacher wanted you to draw Bohr models is going to be different depending on the science teacher you had. If you had Mr. O, he would probably want this. Miss Carr would want something else. Mr. East, because there are a few different ways to model things with Bohr models. And I'm going to tell you what I want to see. What I want your Bohr models to look like is this example that I've given you on this page here. So let's go through drawing Bohr models, and I'm going to get you guys to practice these things. So Bohr models for an atom. It's important to recognize, for those of you who have decided, yes, chemistry is the field of science that I would like to go into, because all of you need to take a Science 11. For some of you, it'll be chemistry or physics or biology or earth science. For those of you who go off and decide to take chemistry, one of the things that you're going to recognize is that Bohr models aren't actually correct. They're useful. Bohr models, let's make a note here, are useful, but wrong. When Bohr, so if you think back to Science 9, you would have learned about the guys who are responsible for discovering what an atom looks like. One of those guys was a guy named Niels Bohr. Niels Bohr developed this model. It's a very useful model, but it's wrong, because then another guy came along behind him, Einstein, and he was responsible for helping put together what the model actually looks like, which you'll look at when you hit Chem 11. So Bohr diagrams are one way of visualizing atoms. They use something called blankety blank to describe the location of the electrons around the atom. These rings, what is the name for these rings? One of the names is shells. So we can call them electron shells. There is another name for these electron shells. Did any one science teacher call them something different? The valence shell is a specific shell. It's the outside shell. We'll get to that too. There's another name for these rings that's not a shell. Did any science teacher tell you something different? If they didn't, that's fine. But if they did, I want to make sure that you know that they're the same. Okay? We can call them electron shells. There's no issue with that. The other name that these things are given are called orbitals. Because you can think of the electrons as orbiting the nucleus, like the planets go around the sun. Again, it's wrong. It's not how the world actually works, but it's useful. It's a useful wrong. How's it going, Mr. Minocha?
Okay,
Sort of, yes.
okay.
You sure?
Yeah.
Okay. These shells. Each shell can only hold a certain number of electrons, which you would have learned last year as well when you were looking at drawing Bohr models for the first time. Does anyone remember what those numbers are? The first one, yes, two. I heard a few places. The first shell can only hold 2 electrons, and then it's full. Only got space for 2. The second and third shells can hold 8. Both of them. And then the fourth shell can hold far more. Does anyone know what the number is for the fourth shell?
16, 36, 18.
We get to 36 as we get bigger. 18 is the next one. So it goes 2, 8, and you can actually, there's a shortcut for this that I'm going to show you. It goes 2, 8, 8, 18, 18, and then the next 2 are both 36. And I'll show you what the shortcut is and how I know that, so that you can also use the shortcut. When you're drawing Bohr models, when you want to fill the shells with electrons, you start typically, and how I want you to draw them just to get used to it, is for each shell, I want you to start at the top. Again, you don't have to. You could start at the side, you could start at the bottom, but I want you to pick a spot that you're going to start each time, just so you can get in the habit of not messing this step up. Start at the top, and then move a direction. You could go clockwise, you could go counterclockwise. But I want you to have a way to organize these things. So move either clockwise or counterclockwise. Be consistent with what you're going to choose to do. And I want you to add electrons like points on a compass. I'll model this for you here in a second. Once you've put one on north, south, north, south, east, and west, you loop back around and you pair them up until you run out of electrons. So once a shell is half full, whatever that number is, you can begin to pair the electrons with each other. So flip the page. Let's do an example when you're ready. Here are my instructions for drawing a Bohr diagram. Again, you've seen this, those of you who had Science 9 in this country, you've seen this before. The way I want you to draw Bohr diagrams is to determine the number of protons and determine the number of neutrons, and then write the protons and neutrons in the middle of the diagram. They are going to represent your nucleus. So these three, the first three steps, are basically the same thing. This is going to give you your nucleus for your Bohr diagram. So let's demonstrate it. The two examples we're going to build here are hydrogen and lithium. You're going to need a periodic table handy, but you can use any of the ones in the classroom here. How many protons does hydrogen have? What is the atomic, another way to think about it, what is the atomic number of hydrogen? 1. So to demonstrate the nuclear part of the nucleus, we're going to put P plus equals 1. The atomic number is 1. How many neutrons are in hydrogen? To find the number of neutrons, you take the mass, you round it to the whole number, and then you subtract the atomic number. How many neutrons? There's none. Someone who said 0, one who said none. There are no. Why? What's the mass of hydrogen? 1. So if the mass is 1 and there's 1 proton, 1 minus 1 is 0. There are no neutrons. N0 equals 0. That is going to give us the nucleus for hydrogen. Let's do the same thing for lithium. What's the atomic number on lithium? It's 3. So we're going to have P plus equals 3. How many neutrons? How'd you get it? So the mass is 7. The protons is 3. 7 minus 3 is 4. Good. So you're going to have N0 equals 4. That's going to give us the nucleus for lithium. Okay, so now let's go back and finish this thing off. What you want to do is you want to determine the number of electrons that the atom or ion, whichever one you're drawing, has. And remember, when you're filling out the shells, most of you said it, that the order goes 2, 8, 8, 18. You're not going to have to draw any Bohr diagrams for anything bigger than that. Because that would just be cruel. Especially since they're wrong. Once the shell's half full, start pairing. So let's go ahead and do this. Then there is an extra step for an ion, which we're going to look at with the lithium one. We're going to make lithium an ion. So for hydrogen, we're going to draw the atom. And in an atom, the number of electrons is equal to the number of protons. So how many electrons do we have to draw for 1? So you put the first shell. We've only got 1 electron. I'll put it up at the top and we're done. Let's do lithium let's do lithium both as an atom, and we'll do lithium again as an ion. We'll do it twice. So let's use the same P plus equals 3 and 0 equals 4. Let's do it twice to demonstrate the two different lithiums. So if lithium's going to be an atom, how many electrons are we going to have on lithium? We're going to have 3. Because in an atom, the protons and electrons are the same. So let's draw the first ring. I need 3 electrons. How many can fit on that first shell? 2. So you put 1 there. The shell can only hold 2, so now it's half full. We can pair it again. We need 3. So now we need to move to the next ring now, the next shell. We only need to put 1 more. There it is. There's your Bohr model for a lithium atom. We put one, it was half full, we paired it. Now the inside one is full because it can only hold two. We jump to the next shell. If instead of an atom we want to do the ion, well, here's the extra step we have to do. We have to put, well, we have to figure out how many electrons are going to be there. So what's the charge going to be on the lithium ion? Take a look at your periodic table. What kind of ion does lithium form? If it's just a plus sign, that means it's +1. So here's what we're going to do. The first, if what you have is an ion, if I tell you to draw an ion, you're going to put square brackets around the diagram. So leave yourself enough space. We're going to put square brackets around here. And then we want to put the charge outside the top right corner. So you guys looked at the periodic table. You said that lithium has a charge of +1. So we're going to put a +1 out here. And now we can go ahead and place the electrons inside there. How many electrons are going to be on the lithium ion if the charge is +1? If the charge is +1, it means does it lose or gain an electron? It loses one. So if it had 3, how many is the ion going to have? It's going to have 2. The inner ring can hold 2. So we put them both on that inner ring, side by side, and we're done. That's the lithium atom. That's the lithium ion. Questions, comments, concerns? Okay, now I want you to practice these. The bottom of the page, there's 6 things. I want you to draw Bohr models for those following elements, and then I want you to flip the page. There's 6 more. These 6, I want you to draw the ions. Chlorine ion, lithium atom, phosphorus atom. One of them we've done already. So that's it. If you can get those done in the next 5 minutes, then you have no homework. But these 12 diagrams, 6 elements, 6 ions, is where we're going to end today, and that's what I want you to do for homework if you don't get it done. Let me know how I can assist you. Follow the instructions that I've given you. On your markets, go.